Solving rational inequalities. So we last left off with the polynomial inequalities. This is rationals, the fraction. So now we're adding in the denominator. So like I talked about, the x-intercepts come from the numerator and the vertical asymptote comes from the denominator. So recall that there are two types of things that go to your sign chart. So now on your sign chart, you have the x-intercepts and the vertical asymptotes. Okay, so for the sign chart for this graph, we have our x, our f of x, and then these three things are going to go on the sign chart. So -3, 3, and 4. Bearing in mind that -3 and 4 are vertical asymptotes, and 3 is the x-intercept. Right. A lot of times I'll note those specifically on my sign chart for reasons that I'll mention here in a hot second. So now we see that, okay, we are negative to the left of 3, positive between -3 and +3, negative between 3 and 4, and then positive outputs to the right of 4. Right? So again, we're just saying like below, above, below, above. That's what we're talking about. Undo, undo. Oh yeah, there it goes. Took a second to catch up. So now if I want, see, what do I want? So if I want f of x is greater than or equal to 0, then we can do, actually, let's go the dark, here we go. F of x is greater than or equal to 0. So that means we want the plus signs, right? Because that is AKA positive. So we want here. So that is -3 to 3 union 4 to infinity. But this is where it's important for personally why I need to note what is a vertical asymptote and what is an x-intercept. Because if I have the or equal to, I'm a bracket around 3 because I'm equal to 0 there, but a parenthesis around -3 and 4 because that is where we have the vertical asymptotes. So just really kind of like word from the wise to the wise, whatever the phrase is. I highly recommend that you also notate what's a vertical asymptote and what's an x-intercept, because you could lose, 6 points perhaps on a test or something if you mix that bracket parenthesis situation. I don't want you to do that. So if I'm strictly less than 0, then f of x is less than 0. We're strictly less than, no line, right? No or equal to. So we're not really worried about the bracket parenthesis thing situation here because it's just all parentheses all the time. So less than here, we want, right, the negative chunks. So that's negative infinity to -3 parenthesis, and then union 3 to 4. That's it. Okay. Remember, your task, your solutions, right, are how do I represent this area? How do I represent this as an interval, right? That's your answer, right? So that's how we get the negative infinity to -3 parenthesis, right? And how do we represent this area, right? Again, that's how we get the 3 to 4. So just keep in mind, you're reading y. Maybe let's see. We read y's answer with x's. Maybe that's a good way to put it. So what if we do it algebraically? What if we do not have the picture? So this is already factored to us, right? We have our x-intercepts from the numerator. That's x plus 5 equaling 0. I don't know why when it's in night mode, it like changes things. Let's see. So sorry. Anywho, okay. I don't know why it gives me white. What is silly? Silly. Like correction. Anywho. So then it is x equals -5 is the x-intercept. The not y-intercept, hello, the vertical asymptote. The vertical asymptote is from the denominator, so we set the denominator equal to 0 and solve. We'll add 2 to every side. So we're left off with x equaling 2. So now these are the two things that go on the sign chart. So x, f of x. Remember, they need to be in numerical order. Again, I'm going to notate that the 5 is the 0 and the x-intercept, and the 2 is the vertical asymptote. If you wanted to go crazy and like kind of make it a pseudo vertical asymptote, if that helps your brain, because again, we do have this or equal to situation. So we need to know that around 2, if I'm including 2, we need to use parentheses, right? Not brackets. So if you, again, want to draw yourself little breadcrumbs, just so you don't go on autopilot like I would never do. I don't do that. Okay. Please do, right? Learn your mistakes or what mistakes you're entailed to make, and then just find ways to correct them. Okay, so that's a long story to say now back to sign chart. So I'm going to choose 0 as a test value. I'm throwing it into the original equation. So 0 tossed in is 5 over -2, which is a negative output. And then we can also use multiplicities for these. So these are invisible, but right, we have even multiplicity. We have 1 as the multiplicity. 1 is odd, so that means we flip-flop, right? Let me put this down. Odd multiplicity. Let me find a better way. Remember, multiplicities. Odd says we cross. Even says we touch or bounce. Right? A little quick pick, bounce, cross. So this would be even multiplicity, and here would be an odd multiplicity. Finish off with my arrows. Okay, where was I? Back to it. Oh, yes. Okay, so now if the center is negative, then I know the signs have to flip-flop. You can totally, if you're like, man, I'm not really confident in my multiplicity skills, I don't really want to rely on that. You can totally choose test values. Slap in your -10. You get what? -5 over -12, which is a positive. If you pop in +10, you get 15 over 8, which is a positive. Again, I don't care what the number is. It's not called a number chart. It's called a sign chart, right? Okay, so now back to the question. The question essentially says, right, y less than or equal to 0. So that means we want the negative chunks. That's here from -5 to 2, right? It has the subtractions. So now we've left our little breadcrumbs, if you will. So we can just say, okay, that is bracket -5 to 2 parenthesis. Ta-da! Easy enough. Okay, here we'll do it graphically just so that because I've learned in my time that students really like the graphical method. They like that visual, and that's totally fine. So x and x, 3 and 1. I have a +3 and a -1. I'm just factoring the denominator. So then I know I have vertical asymptotes at x equaling 1 and -3 from, right, setting them equal to 0 and solving. X equaling 1, and then if x plus 3 equals 0, subtract 3, x is equal to -3. And again, up here, right, this says I have an x-intercept at x equaling -2. But again, I'm doing this graphically. So into y equals, oh, that's good. Let me just turn this one off. Turn that off. And then we'll just look at this one here. Okay, so alpha y equals 1, x plus 2 over x squared plus 2x minus 3. Okay, so graph. Ooh, that's so pretty. So there we go. We have our vertical asymptote at -3, vertical asymptote at 1, and that x-intercept at -2. So now I'm just going to sketch the graph for your viewing pleasure. Let's go, let's see. 1, 2, 3, 1, 2, 3, that 1, boo. And then -2. I don't remember, what was it? Okay, below, come back. Come back. We also know that we have a vertical asymptote, horizontal asymptote at y equaling 0 because we are degree bottom heavy. Degree bottom heavy, right? That's a 1 over a 2. So if we're degree bottom heavy, recall the horizontal asymptote is y equaling 0. So there's below, then we had above, and then we have this S situation. Let's make sure. Good enough. All right. Okay. So you can use it by looking at the graphing calculator, but we're just going to do it by the sketch that I made off the graphing calculator. Okay. So again, you're just going to evaluate, okay, greater than. So that means these pieces. Yeah. So the question is, how do I represent this area in terms of an interval, right? Well, we know that this is -3 to 2, parenthesis, bracket. Oh, no, not bracket, parenthesis, because we are just strictly greater than. Doop. And then we know that this is 1. So it's just 1 to infinity. You can just slap a union and you're like, okay, call it a day. Bingo, bango. Yeah, yes, no, maybe. Okay, we're going to talk about this one because there is a major point that you need to note. Always add or subtract across the inequality. Okay, so what I mean by that is that we are just going to subtract the -1 over. They have 4x over x minus 6 minus 1 less than 0. For this instance, it's like, okay, that's weird, but sure, why? So let me kind of make one up to really kind of hammer it in. What if I had, say, 4x over x minus 6 is less than, I don't know, 2 minus x over x minus 1? Well, to solve something like this, right, we always want to set it to 0. So in doing so, again, I will subtract this entire term over. The entire term gets subtracted, right? The entire term gets subtracted. Why? Because remember, if you multiply or divide across an inequality, the sign flips, right? So a greater than becomes a less than and vice versa, right? So if you were to do some weird combination of like cross multiplying or something, you don't know if you should flip the sign, right? Because you don't know, did you just multiply by a negative across the inequality sign? Did you divide by a negative across an inequality sign? We just don't know. So because of that, We just do not do it. That is a big no-no. Okay. Big no-no. You just add or subtract. No big deal. Okay. So back to this problem. I, as you saw, have it in the calculator already. So I'm just going to delete this one out. I don't clear it. Yeah, okay. So let me turn this one back on. Graph. Zoom it out a little bit. We'll see. I haven't bought it, so it's like, nope, this is your window. Sorry, Toots. Um, but notice we have a vertical, or excuse me, a vertical asymptote on the right-hand side, somewhere between what, 5 and 10. Horizontal asymptote maybe at like 2. I could tell you specifically, but basically you have these boomerangs across from each other. It looks like something like this. I know it's 6 because that denominator is 6. And this horizontal asymptote is at 4. Oh, actually, we cross paths at 0. There we go. X-intercept at 0. There we go. So the easiest way to go about this, or I think it's a 4, let's find out, is to change 1 to just be x minus 6 over x minus 6, because what's anything over itself? 1. So then this is 4x minus x minus 6 all over x minus 6 equal to 0. Distribute the negative. So 4x minus x plus 6 over x minus 6. Okay, so it's 3, not 4. 3. So 4x minus x is 3x plus 6 over x minus 6. The leading terms are degree equal, right? So that means the horizontal asymptote is the ratio of the leading coefficient. So that's how I knew that the horizontal asymptote was at 3, or now I know. And you can see here in blue, right? We get vertical asymptotes from the denominator. So that's how I knew we have a horizontal asymptote at x equaling positive 6. Vertical asymptote. Perfect. So then if we go back to the question, looking at the original right here, this says, where is f of x less than 0, right? That's what we're answering. So that is this section right here. Let me change this. Right here. So that is 0 to 6. And we're strictly less than, so all parentheses all the time, right? Because we are just trying to figure out, how do I represent this chunk of the x-axis? There we go. That's the words I'm looking for. Words, they work. Okay. Okay, that's, intense. But I think some of y'all will realize like, oh, I really enjoy the graphing. Okay. Others of you will realize like, oh no, I'm totally all for the algebraic. And that's fine. Both are totally fine. I just need to know, remember, if this is on a test, that's all you're going to see. Solve and then an equation. It's up to you to know what that means. Just like as you as a driver, it's up to you what it means to go up to a yellow triangle. Yield. Right? Okay. Then next video moves on to exponential functions.